Hello. This podcast is on quantitative analysis of friction. First, we're going to learn about what causes friction. We're going to look at the key quantities that affect the strength of the friction force, and we're going to learn how to quantitatively analyze friction. What is friction? Friction is a force that always opposes motion. It acts parallel to the solid surfaces. It keeps objects from moving. It slows down objects that are moving. And because of friction, a constant force is required to maintain an object in constant velocity. So what causes friction? Here we have an example of a heavy wooden crate on a concrete floor. And friction is caused by two solid surfaces coming in contact with each other. All surfaces have microscopic peaks and valleys. So if you look over here at this blow up of the microscopic level, or I should say at the microscopic level, even surfaces as smooth as metal and ice will have microscopic peaks and valleys. And the peaks of one surface settle into the valleys of the other surface. You can see examples of that right here in our microscopic blowup where the peaks and valleys are settling in. What happens is where they settle in, it creates numerous small push forces that oppose motion. Now, let me just say, this explanation I just gave you is one model of friction. We don't have a perfect understanding of friction. There is no one model that fits every case, but the one I gave you here is currently the one that works the best for us. Let's move on and talk about what affects friction. We're much more certain about that. First, motionless versus moving. Something that's motionless will have a higher friction force than the same object when it's moving. And in physics, we use the term static friction to mean the friction force of an object at rest, and we use kinetic friction to mean the friction force for an object that's moving. And the reason for this is when an object is motionless, the peaks and valleys get to settle in more with each other and they interlock more tightly and create those stronger small push forces. Speed has no effect on the friction force. The friction force is the same whether an object's moving at half a meter per second or 5 meters per second. The big difference is it stationary or is it moving? But once it's moving, the speed has no effect on the strength of the friction force. Mass does affect the friction force. The friction force increases as the normal force increases. So it's not mass itself, but it's the normal force of the surface pushing up on the object. And of course, if we increase the mass, we're going to increase the normal force. And the reason for that is the increased mass causes the normal force to press the two surfaces together, and that interlocks these peaks and valleys even more, making the friction force stronger. And finally, surface texture affects the friction force. The friction force increases as the surface texture gets rougher or stickier. We believe this happens because rougher and stickier surfaces have more valleys and peaks that are deeper, so that allows them to interlock more tightly and increase the friction force. Let's turn now to quantitatively analyzing friction, and here's the equation that we use to calculate the strength of the friction force. Let's take a look at it in terms of our model or explanation of friction. First, we have the normal force, and that's telling us how hard these two surfaces are pressed together. Next is this funny looking U, which is actually the Greek letter mu. It's the coefficient of friction, and it takes into account two of the factors affecting friction. The first factor is whether it's moving or not moving. And for an object, the static coefficient of friction is always going to be larger than the kinetic coefficient of friction. The coefficient of friction increases as a surface gets rougher or stickier. So surfaces that are rougher or stickier will have a larger coefficient of friction. We can go ahead and take our general equation and break it into two different versions. If an object's stationary, we say that the static friction is equal to the static coefficient of friction times the normal force. And if the object's moving, we just say that the kinetic friction is equal to the kinetic coefficient of friction times the normal force. We can rearrange this equation and solve for the coefficient of friction. So in some problems, you'll be given information about the friction force and the normal force, and you'll be asked to calculate the coefficient of friction. and you would use this version of our friction equation. Let's move on and look at a problem. You drag your 5-kilogram backpack across the floor with a force of 50 newtons. The kinetic coefficient of friction for your backpack and the floor is 0.20. Draw a quantitative force diagram, and what is the backpack's acceleration? We go ahead and we have our force diagram, and of course we draw our vertical forces, and they're balanced. We have the friction force going to the left and the tension force of us pulling the backpack going to the right. Next, we need to calculate the forces. So if we look at the weight, we calculate the weight is 49 newtons, and that's the force of gravity in the negative direction. We know, since the vertical forces are balanced, that the normal force is 49 newtons in the positive direction. And then we need to calculate the friction force. So we're given the coefficient of friction, and we multiply that by the normal force, and we get the friction force is 9.8 newtons, and of course that's in the negative direction, and we fill it in there. And then lastly, we need to calculate the acceleration, so we use Newton's second law. We rearrange it to find acceleration. We add up the horizontal forces, because that's the dimension in which the backpack's going to be moving, and we divide it by the mass of the backpack, and we find out that the acceleration of the backpack is 8.0 meters per second squared. Let's look at another problem. You push your car across the parking lot. The static coefficient of friction is 0.10. If your car has a mass of 1,200 kilograms, how hard must you push to get the car moving? Here's our force diagram. We have the vertical forces, gravity and normal, balancing each other. You're pushing to the left on the car, so the friction force is pushing to the right. First, calculate our force of gravity, and that's 11,760 newtons in the negative direction. And because the forces are balanced, we know that the normal force is 11,760 newtons. So we need that information about the normal force in order to calculate the friction force. We're looking, because the car is not moving, we're looking at the static friction. So that's equal to the static coefficient of friction, which is 0.1 times the normal force, and that gives us a friction force of 11,076 newtons. To get the car moving, we've got to push harder than that friction force, so our force has to be something larger than 1,176 newtons. Let's take a look at one more problem. You're pushing a 20-kilogram box across the floor at constant velocity. You have to push with 50 newtons of force to maintain a steady speed. What is the coefficient of friction between the floor and the box? So here they've given you the push force, and they're asking you to find the coefficient of kinetic friction. First, we have to do our force diagram. We have our vertical forces. We go ahead and calculate the weight. So we know the force of gravity acting on the box, and then that gives us the normal force, which is just the same strength but in the positive direction. We put in our push force to the right, and we know that's 50 newtons, and because the box is moving at constant velocity, we know that the friction force is just as strong, 50 newtons, but in the negative direction. We've got all our force information. Now we have to use our new equation about friction to find the coefficient of friction. We know the friction force and we know the normal force, so we need to rearrange this equation to solve it for mu, the coefficient, in this case, of kinetic friction. We go ahead and do that, plug in our friction and normal force numbers, and we get negative 0.26. Typically, we report coefficients of friction as positive numbers, so I would write this as 0.26, but if you left it as negative 0.26, I would never mark that wrong on a quiz or test. Well, this wraps up what we wanted to learn, so let's just summarize what we've learned. We know friction opposes and hinders motion. The force acts parallel to the surface. Friction is caused by the microscopic peaks and valleys, causing numerous small push forces against the motion. The friction force is stronger when an object is at rest, we call that static friction, than when it is moving, which we call kinetic friction. Increasing the normal force increases the friction force because the surfaces are pressed harder together. Increasing the roughness or stickiness of the surface increases the friction force because there's more and or deeper peaks and valleys. The speed of the object does not affect the friction. It can be going slow, it can be going fast, but it doesn't affect it. And finally, we have our friction force equation, which tells us that the strength of the friction force is equal to the coefficient of friction times the normal force acting on the object. I hope you found this podcast helpful, and have a good day.